Yeah, my name is Caleb Grable. I am an R&D engineer for Enduralock. We're based in Lenexa, Kansas. And what we offer is vibration-resistant fasteners for aerospace and space applications. And why that comes into play and why that's so important is in the lunar environment or in the space environment, you have extremes of temperature and you have a very dire need for vibration resistance. And so we have a couple of fasteners. One is the Silverlock, what we call the Silverlock nut, and you can see it here. What you do is you take a standard 6-point socket and you place it over a spring that has teeth on it. That teeth engages a lock washer that's constrained by the flats on the bolt. And so this can't move, and so when you deform these tabs, it allows for free rotation of the nut, and then when you remove the Silverlock, or you remove the socket, it jumps into position and then you're locked. And that comes with around a very great torque gradation, a lot of opportunities to narrowly control the torque, basically. And so that's our Silverlock. We've miniaturized that through a SBIR contract to a number 4, number 10 size fastener. So we've taken the Silverlock, miniaturized it, and then we've also developed a end effector for robotic assembly in space, and we have a TACFI that's pending to further develop that end effector with an ultrasonic probe using an electromagnetic acoustic transducer. What we also offer is a self-aligning nut plate for robotic assembly in space. So if you have, let's say, a panel that you need to remove or replace, what you may run into in an existing nut plate is you have some misalignment that then would cross-thread your nut plate and then prevent you from removing the panel and would ruin that assembly. But what we've allowed for is both axial and radial misalignment, and so when a robot comes in, screws into here, you're able to account for that misalignment. So that's our technology in a nutshell. We also have an STTR that's developing a multi-contact electrical and mechanical connection method for modular satellites called CubeSats, up to a 12U. We're currently at a 1.5U. For space development, I would say the ability to assemble in space and also to have highly vibration resistant fastening solutions. So you can send things into space that are vibration resistant, but you can't currently assemble in space due to the fact that you can't safety wire in space. And so safety wire is currently the only option, or one of the few options to create a vibration resistant fastening solution. We offer a both reversible, reusable solution for space assembly. And the other thing I should mention is that it's 10x the National Aerospace standard for vibration resistance. Then also, like I said, robotic assembly. So you can take a highly vibration resistant fastener and one that also allows for a lot of misalignment.